afternoon, everyone, and welcome. We're slowly letting the attendees join and kind of get folks in here and loaded. But welcome, everyone. But we're absolutely glad that you are here. My name is Mike Cool, Strategic Marketing Director for Element Materials Technology, supporting our Aerospace and Energy Business Unit, and it's great to have you with us. Today's session focuses on fuel system and component testing, and just as importantly, on how to effectively work with test suppliers to deliver successful outcomes. We'll cover both the technical side and things like endurance testing, environmental control, fuel icing, and contamination, and the practical realities of executing complex test programs. For many of you working in this space, you know that testing isn't just about capability. It's about communication, alignment, and trust. So today we'll share some insights on how to structure engagements, avoid common pitfalls, and build stronger partnerships with your testing teams. I'm joined by two experts who bring deep hands-on experience in this space. First, we have Dan Prano, Technical Director with extensive expertise in hydraulics and fuel testing, including fuel icing. Dan is also an SAE AE-5 member and the primary author of ARP 1401 Charlie, bringing both a practical and industry standard perspective to our discussion. And also we have David Alberti, Senior Test Engineer who specializes in fuel system testing, custom rig design, and project execution. David brings a strong operational lens from working directly on complex testing programs for a variety of customers. Together, they'll walk you through both the technical capabilities and the real-world execution of successful testing programs. With that, I'll go ahead and hand it over to you, Dan, to get us started. Thank you so much. We have, of course, a Q&A ready to go whenever. Just please type a couple questions in the Q&A, and we'll be sure to address those as they pop up, as well as, of course, the attendee chat is live, and we are monitoring that as well. With that, Dan, it's all yours.
Thanks, Michael. I appreciate it. What I'll do here is I'll do a quick introduction into Element, their product qualification groups, test facilities, and then we'll focus in on, again, the fuel and hydraulic side of the Jupiter lab. So to begin with, we essentially have a few different places that do this type of work. One is our Bloomington lab in Minnesota. They have a fire test facility. They do some hydraulic and fuel tests there as well. And they're kind of specialty areas. They have an excellent EMI lab, and they can combine those to do operational EMI testing and hydraulics and fuel. A counterpart to them is out in Alabama. So we have the Huntsville lab, and they don't do oil and fuel testing, but they do true hydraulic work with water systems and steam, and they do service primarily the nuclear industry. They got some very large and high pressure, high temperature capabilities, and can do a lot of work that other labs in the world cannot do. And then our third lab here is from Boxborough in Massachusetts. And they have they cover the fundamentals of the hydraulic testing with pressure cycling, static pressure and burst. And they can also use those kind of capabilities to add into standard environmental or dynamics work in their lab as well. But compared to those, we have the Jupiter location, which is where Dave and myself are housed out of. And this is what we call a center of excellence for hydraulic and fuel testing in our North American group. Really, the Jupiter facility brings in hydraulic and pneumatic capability of all kinds, whether it's fuel systems, oil systems, water, bringing air together. And it allows us to have these combination of both system level tests and component level. It's something where we custom design and build test stands routinely. Most every job we do is unique. And with that approach on component level testing, it isn't really that much further of a step for us with our design background to take that to a system level as well. And one thing that kind of, again, specializes this location is that we don't really have a lot of shake and bake work. A lot of our work is complex in nature. And so our entire staff here, the entire location is trained and tuned to do these special kind of tests and these different approaches that the testing we do demands. And so it allows us both simple work we can get through and also very complex testing as well. Similarly, that approach gives us that kind of broad spectrum of everything from procedure writing to the test report. So if you need assistance with doing the test, that's great, we can do that. But if you also need ideas on fabrication of fixtures, design of and writing of test procedures, we can cover that full gamut, as well as instrumentation and controls as we automate and build, again, custom test stands. And so that's really what allows the Jupiter site to excel as that center of excellence for hydraulic and fuel work. It's everything we do is custom and scalable to whatever meets your needs. And so what we're going to do from here is we're going to do our first poll question. And this is where we're going to ask you to participate here and just select which of these labs I just introduced have you had the most personal experience with, whether you're a customer or just asking quotes for them or you've emailed. If you're not familiar with any, that's perfectly fine too. That's an option for that as well. We like to know your background and your exposure to the element groups.
Hey, Dan, while we're waiting on that poll to get answered, I actually have a quick question for you. What hours of support does Element Jupiter provide to accommodate the long nature of these endurance tests?
Okay, so yeah, the Element Jupiter lab has the ability to do 24/7 operations, really. It's something that we stretch our support to meet the needs of the test approaches. So we're going to cover some of these long duration programs in the next slide or two. And again, our ability to deliver those, whether it's automated monitoring or in person, we can support the needs as they come.
Outstanding. Thank you so much. And please keep the questions coming, audience. This is fantastic.
And we'll give just a little bit more time to answer this question. We'll move on to our next portion of the presentation. What we'll do next is we're going to be covering kind of bits and pieces of different tests we run into and the main ones that require quite a lot of attention and effort for. And we'll cover a little bit about why that testing is important and how it impacts our customers, and then also what a test house should be looking out for when they are getting prepared for these. Again, the intention of most of this presentation following is a little bit of insight to the Jupiter's facility, but also really to encourage our customer and the folks listening how to deal with a test house as you are preparing for your testing, right? It's a guide for you. So it looks like we probably have all the feedback we need for this question. So we'll go through it. It seems like most of them is familiar with Jupiter, and that's not a surprise, I suppose, knowing the content what this is primarily about. And I'm glad we could introduce some of the other labs to the team here.
Well, honestly, the video that we've gotten and the few visits we've had to Jupiter, Dan, have been pretty awesome. So I think it's a great facility to know just in general.
All right, so we'll kick this off to the first test program. We'll allow David to go into endurance testing for you.
Yeah, hello all. Here I'm just going to discuss one of our hot topic items here is endurance testing. So these can be quite interesting in the setup or what the application requires. So a lot of things you have to consider with this is these tests have a big schedule dominance, and customers want them done immediately and don't think about any of the facility parts of it. So you actually have to consider the actual maintenance of facility components, or even test article maintenance if it needs to be included in your test program. Depends on how long it is. So basically, we can accommodate, a couple different ways to monitor these tests. If they're a shorter duration and it's not as complex, it may just require technicians monitoring it during daytimes. Or, if you want to accumulate as much hours as you can, we'll turn this into a fully automated setup. So we'll have a data acquisition system, just continuously monitor the actual the test parameters. Number one, we want to make sure that we're running our test unit within the specifications that we're given. The other part of it is we actually want to monitor facility equipment if there's not going to be personnel standing right there to continuously watch it. So with that being said, is we can actually integrate automatic shutdowns or alarms into our software or the actual hardware of the facility equipment. So we can safely run this without actually having personnel be there. So like Dan was alluding to before, is we can run tests for 24/7. So personnel doesn't actually have to be on site. We can, continuously monitor it, whether it's through, a video link, that we can actually check in over the weekend when nobody's in. And we have full capability of having software control everything. So another part to this is, we'll actually have, the software can, in some setups, we can adjust the test parameters. So you wouldn't even need an operator there too. So that's another big aspect of it too that you would want to think about. So we try to keep as much uptime as we can on the equipment. So we come straight up, talk with our clients right up off the bat of, we got to be realistic. We're going to have some kind of shutdowns for maintenance. And, we work through that. So there's no surprises of, this may take several weeks longer than anticipated. So one other proponent of this we want to introduce is, if you want to monitor the test and record data, is how much data is too much. So you might want to have some kind of test that's cycling and you want to have a high resolution data, which we can actually take little snips of that and, at whatever period, and we can investigate to make sure that we're still running to what we need to be. And that actually cuts out a lot of just, data that may not be that useful to us. Another test, one of my favorites is fluid contamination. And even when you can combine this with endurance, gets it a little more interesting as well. So, here we will have, customizable injection systems. So depending on what the needs are, we'll actually work with our clients to help guide them to the best solution to their problem, what they want to actually test. So we are capable of multiple fluid circuits at the same time. And for, the biggest portion of this contamination is, how much contaminants are getting to the test article. So that is the biggest challenge with this. Contamination in systems don't do well, even for facility components. So you have to be very careful of how that's actually set up. Your filtering means your monitoring of how your injection is going. So we actually have several different methods where we monitor our tank consumptions if we're using a slurry method, or if we're doing a direct contamination injection, we'll quantify how much actually went to the test article. Another component of this is, for say like an endurance contamination test, we want to have a constant monitoring of what the test article is doing. If the component fails, we don't want to just keep running it uselessly. So we have methods of actually alerting technicians of, something is going on. There's some kind of anomaly happening. So,
well, knowing that on this topic, David, we got another great question from the audience. What is the best method to inject that contamination, and why?
So we want to do a single pass injection where you're basically putting the contaminants directly to the unit. And this is going to be the most representative threat, as opposed to you can do a dosing method where you're batching a tank and you could recirculate onto itself and you may lose part of the contaminants within the test facility system, or you may run into the predicament of over testing the unit, putting too much contamination through the test article initially. So picking your actual approach is pretty crucial for these setups of how you want to introduce your contaminant to your system. So another component of this is, obviously is how we're putting it into the system. We want to think about also the contamination prep. So just the humidity in the air can affect your contaminant. And if you're introducing it by mass, you want to make sure that your contaminants are dry with no no unwanted water in the actual mass itself to cause other issues with the system. So that is something that commonly gets overlooked, where we'll just take a contaminant out of a jar and just introduce it to the system, and you could inadvertently be putting something else into the system you wouldn't want.
Mhm. Oh, very good to know. Thanks, David.
Yeah, I think just to wrap that up, I think the last part on contam was the idea that customers really should be involved in the contaminant introduction process. There's a lot of test standards out there that they do tell you what you need to do, but not how to do. And it's something that we highly recommend, whatever test house you use, that's a discussion you take with them, their engineering team, and you make sure the approach both makes sense and will give you something that is representative. Like, again, there's a lot of ways to approach this test and some that are not as ideal as others. So another quick point here. Again, we like to cover a variety of tests we have within our facility, and fire testing is another one. This is one where there's a new standard that has been released last year for fire testing, trying to harmonize a lot of fire tests together that are very similar, but the standards do have some conflicting information. So that's been out there. We have a setup now that meets those calibration requirements that are there. Our team's part of the groups overseeing those standard revisions and all that. And then another feature, I think, just to highlight here when we talk about fire testing, is our ability to do smoke toxicity. It's something that's fairly unique in the world, and the scope of that really is trying to take gas samples from your test article as it's burning to try and establish the toxicity or the gas makeup of your outgassing. And we can do that over different periods of time throughout the burn and have a large collection of samples we can analyze post-test. And that's something that is not really found within any commercial laboratory other than the one here in Jupiter. But, just again, for advice when you're preparing for fire tests, this is something that the most common issues we run into with customer preparation or the communication between us and them is trying to make sure you have a good fixture and clearance designed for your fire test. A lot of people, when they prepare their test plans, they think about the most vulnerable area of their test unit. They don't really consider that the burner is going to impact another nearby component or a feature. And so it's important to have clearance there and making sure materials are designed not for aerospace and putting in flight, but for being burned and having a fire on it. You can prematurely cause unit failures by bad fixture design. And that's something we really want to be aware of. The second piece of this I want to mention, we'll hit on this again with our hot test cells, but it's rig safety. So whenever a customer approaches a test facility, you often assume, rightly or wrongly, that the facility is safe for you to be present in. And for the majority of tests, that's a fair, reasonable assumption. I think with fire testing, especially with fuel systems and fuel components, we just urge really everyone to take a moment to understand what the risks are for both people on site, your equipment, what happens if things go wrong. A fire test facility should be communicating, where you should go and what's the next steps if there's an emergency in that area, and making sure that people are safe as they're witnessing testing. So we have a lot of things in place to help protect our people and our equipment, but not every lab's the same. And so again, just for a bit of awareness, ask around. The second piece here is something that we have a lot of experience and fame with, I suppose, is our fuel icing facilities. So we do have 5 large fuel systems here, ranging from 1,000 gallons up to 4,000 gallon fuel tanks. And we have a lot of experience both with steady state and transient. Transient, I think, is something that the industry has definitely got introduced in the past 10 years, and it really didn't exist much before then. And we have a couple variety of ways to actually approach transient testing with either ice injection or water injection. So when we talk about fuel testing and fuel components or system level, this is a great example of tests that we can kind of combine and do both. If you look at the standards that guide fuel icing, there really is one primary standard for guiding steady state icing, and that's ARP 1401C, which I'm a primary author of the latest revision. And we're looking to write a new version or new document really to cover transient icing, because there really is no guidance towards that yet in our industry. And so knowing that and the evolution of testing as it's been in the past 15 years, I think from a supplier trying to get their product through testing, you really need to be aware of those changes of interpretation. What has been accepted for testing with field icing in the past 15 years may not be allowed at this point in time. It's changed quite a bit. And that's changed from a regulatory standpoint, although the regulations themselves haven't changed, but the interpretations have. So I walk through that with your test supplier, make sure that they're aware and that you're aware of what you can and need to have for testing. And how you do water addition will effectively make or break this quality of this test you do. And one thing that's definitely required, especially now, and it's written in the latest version of the ARP 1401, is water validation. And it's best to approach this from the beginning about knowing how after test or during test are you going to validate that the water has been and the ice has been, the unit's been subjected to, and that you've quantified it. So these are essential, things to understand as you approach these tests and get prepared for them. So move back to David.
All right, thermal performance. These tests can actually have their own challenges to themselves. So, what we're capable of here is we can run these with multiple circuits, different types of fluids, and we have robust data acquisition systems to accommodate what we're trying to do. So one of the biggest items that people overlook of this is they want to just jump right into testing, build some kind of fixture, and not really think too far ahead of, maybe different points that they would like to run with their system. And that causes all sorts of headaches. So one thing you want to actually keep in consideration is, how much instrumentation do you need, and, the quality of it, what kind of resolution do you need on transducers or thermocouples. So these are really challenging because you're going to have fluid circuits that, don't tend to want to be homogeneous. So you have to add additional methods in to try to make your circuits homogeneous. So you're going to actually have a good heat balance estimation between them. So when you're dealing with the pneumatic circuits, that's another animal where you're going to have a lot of stratification of air through some kind of matrix. Actually picking distance from, the heat exchanger and the types of thermocouples, or, the array of it, is a real challenge to be representative of what's actually happening over the whole core itself. So that is something to not take lightly on actually coming together with a fixture design of, how you want to put this together, what you're expecting it to do. And then, ideally the best way to run these tests is to, if you have a reservoir big enough, you'd want to run single pass on your fluids. You precondition it, you send it through your unit, and you're done. But in some of these instances, you're not able to do that, where you have to recirculate onto itself. So in doing that, you have to have an estimation of performance the unit is going to have, so the facility can match their equipment to outperform the actual test article. So we have some buffer to, make adjustments. And then coming into high temperature fluid testing. So
actually, before we hop into high temp fluids, David, we've got another quick question on thermal performance. What is a common mistake a test facility makes when planning for thermal performance testing, and how can that be mitigated?
I could Dave, if you like.
Yeah, go right ahead.
Yeah, I think when preparing for thermal performance, often what happens is a facility is chosen because they can do fluid circuits and they can build an oil system and a fuel system or an air system, right? And it's a very gross misunderstanding to go into a design with the single circuits in mind. as David was inferring, that if you pick the wrong instrumentation or the wrong accuracy of instrumentation, if you're not using RTDs or an array of thermocouples that kind of are mass balanced with the flow going through them, there's a lot of issues you'll run into. Yes, the basic systems work by themselves, but in combination with thermal transfer, if the unit's not insulated enough, or it's not, there's not padding between it and the stands holding it in place, and you're getting conduction or a lot of radiation coming off, you're going to have erroneous readings. So I think a lot of people approach it with an oversimplified thought that it's just two fluid circuits, and that's what makes thermal performance so much different than a pressure drop test or an endurance test program.
Outstanding. Thanks for the answer. We actually have more questions rolling in. I think we got time for a quick one. Andrew asks, what software is used to acquire and log the test data?
We'll cover that on a later slide, although we can mention it now that our lab. Yeah, we can. So our lab uses a program called Daisy Lab. It's a sister program of LabVIEW, and we use it here for both controls and data acquisition combined. So it's able to do everything we need at whatever speeds we need it to.
Outstanding. Thank you.
All right, David, probably back to you for your next one.
All right. High temperature fluids. So this is one that we've been doing it so long that it's became second hat to us. Obviously the biggest issue you're going to have here is you're dealing with high temperature fluids that are fluids above flash point. So there's a lot of energy in that media, and you want to think about safety, number one. So in our facility we have two large class 1 division 2 test cells that are capable of housing some pretty dangerous systems in there. So we have the capability of heating fuel above 300 degrees and doing it comfortably. So these cells are equipped with hydrocarbon sensors, oxygen sensors, leak detection. They have interlocks, so when fluids are at a dangerous state, you don't have entry to the cells. We actually will monitor it from outside the cell via a camera system if need be. So we have a lot of confidence running tests like this, and these are large enough cells that we can build complex setups in there with multiple circuits, different types of fluids. We can put driveline tables in there as needed. Even if we wanted to, we'll get hot air in there. It's basically will accommodate whatever we need to do for that test requirement.
Yeah, I think a good transition away from this is similar to fire testing, which is for safety, right? So for people witnessing testing or asking a test house to do one of these high temperature tests, it's there's not much, you don't want to leave room for them to get themselves in danger, right? So again, this is where and you'll see later on, I'll talk about communication, but having a good dialogue between the supplier and the requester for testing is essential to keep them safe, to keep you safe, etc. So, and have those conversations. You don't want to assume or set them up for failure when you may know better, and you want to do it somewhere else and they don't know. That's the worst condition that we could be in for testing. So moving from that right into a couple other ones. These are fairly quick slides here, but we do some low lubricity testing. It's pretty rare to do, generally speaking, but it's very challenging to do. And it's one of those tests where you take a hot fluid or hot fuel and you remove all of the lubricity out of it with clay bed filters. And we have on site the Bockel tester, so we can get a wear scar measurement live. That's how you measure how much lubricity your fluid has. These tests, I think the thing to know when you approach these, again, is that they're actually pretty costly. The tests aren't very long, but you have to maintain fluid at a certain condition, and you have to have certain materials in your rig, and avoid certain materials when you build these rigs. And so that makes these a little step above most hot fuel projects, where it's not only a safety issue, but it's more expensive materials and more management of the test fluid as you go through testing. So again, just things to be aware of when you approach a test house for these. The next one is, behoove us to mention again, a system level testing. This is something where we've done this for a number of wing systems and engine systems. And like I mentioned at the beginning, the Jupiter Lab's really built around custom projects and things that we piece together. Whether it's a component test or system, we take these all quite seriously with design work, with internal processes and reviews. So we can approach these kind of projects in a variety of ways. And one thing to keep aware, again, when we see system level or test requests come in, there's often times where we miss the identification of true boundary conditions, right? With a component, it's pretty straightforward with usually that one device and what it needs. But when you have a system, there's a lot of pressure, temperature, flow conditions you need on multiple circuits. There's electrical requirements for different components. There's geometry that's required for installation and securing things in certain attitudes and heights and altitudes. So this is something that's often missed, and you want to spend a lot of time here making sure that the boundaries of the entire system are well understood, and also defining what it is to be successful and safe with the product, right? So if there's a condition that's going to cause damage to the system level or unit level, then we need to have those identified so we can run these kind of tests safely. And move on to the last two. This for the data acquisition again. You can take it over, David.
Yeah, absolutely. So for the data acquisition that we do here, as Dan said, is we use that Daisy Lab program. A lot of our hardware is National Instruments, so it has expandability that we can build custom systems as we need. We do have several systems that are already pre-assembled in-house that are always ready to go, that we can move test to test. So something that we do here too that's very critical to the work is we verify all the data that we're going to be giving to the customer. So we do this in the actual setup phase where we'll instrument a test stand. We'll run all the cabling, wiring, everything to the data system, and we'll put our scaling into our data system, and we'll use a reference calibrated gauge, some kind of standard on the actual instrument side, and we're going to verify our readings from the data cart to our reference standard. So we ensure that there was no just accidentally putting in the wrong channel or something of that matter. So we know we're certain that the data that is getting to the end user is, accurate. So we take that pretty seriously here. So in these test setups is, we want to think about what our actual conditions are going to be. So this is the discussions we have with our customers ahead of time. What kind of boundary conditions that we need to set for, each parameter. So we'll actually set up a live readout of what the actual test, what the test system is doing. So whatever it is, a pressure or temperature, and we can put high and low limits on a live readout. So it's basically, we're doing data review as running. So we can run several hours of data back on a screen, ensure that it was within parameters. If somebody isn't sitting there watching it, if it's a long duration, we can come back cycle by cycle to ensure that the test article is still doing what it needs to be doing. So we like to also have the conversation with the customers where, if we're doing an extended run, we'll call it a soft limit for, even if it's a test tolerance and it goes above it, we have a discussion. Well, what does that mean? Do we want to shut the rig down? Is that immediate means for aborting the test? But it will open up a range where it's not going to damage the test unit. We can continue the run to minimize any downtime. It may be a little bit over test, but it'll still be acceptable. We don't want to just jump into a situation if it runs out of tolerance for a second and just shut down a test stand. So then we'll have the other discussion of what's actually going to damage your test unit and what conditions don't you ever want to see. And if we get to that level, then we'll have we can program in an automatic shutdown of the system to preserve the test unit. So that's one key thing that we do here. Also, we're very clear on what your data requirements are, what channels you want to actually have recorded, and what kind of data rate. And then, just as discussed, we can do the safety limits of, we can actually even put audio or visual alarms on the test setup. We can, just have other means of monitoring the test where it can prompt you of, something happened so the operator can come back and see, that the anomaly has occurred and something has to be, some action has to be taken on that matter. So I think that's pretty much it for our test monitoring here. I don't know if you have anything else to add to that, Daniel.
No, we're all good.
I have a quick question before handing it off to Dan. What does a customer need to provide you to program in controls and limits to run the test rigs and automate cycling?
That's a good question. All of our test engineers are very well trained in doing the software as well as their mechanical engineering to build the rigs. And so you don't really have to provide much. Again, it's just if it's tolerances for your test conditions, if it's safety limits, that's really it. We don't really require much out of our customers in order to automate or build rigs. That's really all done internal, and it's something that we're prepared to do. If you want, we can implement, good and bad cycle counters or over test counters or whatever else to kind of add some extra flair to the test rigs. We can do that, but it's all done internal. We don't need it. So if you want it, ask, and then we'll see what we can accommodate.
Outstanding. Thank you.
Yeah, I think we really only have one more quick slide here before the last segment. And so that's the field chemistry. I think maybe I'll just...
We'll sit here and then go for it.
Yeah, I'll knock out real quick. This is fast. I mean, essentially, the Jupiter lab, because of the work we do, we have a lot of testing we can do on site. So we train our employees in how to do a lot of the chemistry analysis too. And so these are example tests that we can run. I'm not going to spend too much time there. I think the idea is that we try and incorporate things internally so we can just expedite turnaround times. So you don't want to take a test, a sample out of a fuel rig and then send it out to a third party and wait a week before you get a result. And so that's something that we can do a lot of these inside. This is a short list. We can do more than this, but these are prime examples of things that can help expedite our testing. So the next slide, I'll introduce it before we go there. This is another poll question, and it's I'm gonna go there. It's a negative space, and so the question is, what has defined your worst experience at a test facility? And I think this is important because while you're answering that, I just pick something that stands out. When you think about the most frustrating experience you had, what do you think the root cause was, or what do you think the primary reason that brought that frustration? Because we really only have 2 more content slides after this, but they're a little lengthy and they deal with this specific issue. And so while you're thinking about that, we like to know, what is the largest pain points of our customers here too. But I think we have good solutions to help prevent a lot of this from happening. Yeah, we see some good comments coming through.
I know we get to see a lot of the customer surveys and post-action surveys on my side, Dan. So I think I know what the answer is. I'm curious to see.
Maybe we'll let another 30 seconds or so here go.
Any good tests going on today, Dan?
Always.
It's the last day of the month. I know you got something on the rig out there.
Yeah, they're always pushing. All right, I think we can probably move on there and show the results we got. Let's see what we have. Technical experience, communication, and accountability. Yeah. So yeah, I think I wouldn't be surprised if all of these options were picked. Again,
Yeah.
we don't have a selection here, but it's something that these are core things. I think a lot of these are related in certain ways. So I have 2 slides left. I know we've been going on a bit. We got 2 slides here, and we're going to cover how to mitigate some of this, right? Because again, what I'm doing is from a test house perspective, I want to give suppliers or component manufacturers advice on how to navigate work with a test house to avoid this. It's definitely every situation, there's 2 people involved, 2 parties. And so I can kind of give some insight on a good way to engage, right? And a lot of this is going to keep coming back to communication, right? So the first thing really is a contract review. Sounds so simple. Most engineers don't want to deal with this themselves in a conventional sense, but when you have a simple test, we'll start with that. When you have a simple test and it's a very transactional test, a lot of these advice are needed because it's something that you expect it to be done. If you're doing a tensile test or something, you send parts in. And you don't need to engage with your supplier very much. But when you're dealing with these custom rigs we build, and you have a need, and it's a test plan you create, and you spend a lot of time writing, a test house should give you a quote with some good commentary or assumptions or something that lets you know that they understand your request. And the worst place to start a job is on the wrong foot and not seeing eye to eye. So before a job is awarded somewhere, my recommendation on all levels is to talk to them. Make sure you read what they wrote, the test lab. If they have assumptions or caveats to their quote, make sure you read it, but then ask them questions and have a dialogue and get that started early. If there's a bad dialogue up front, they're not going to be a good supplier is my recommendation to that. And if they misunderstand something and you guys go into a job and they start building and proceeding forward, you're also not going to have a good experience with it as well. And so some simple things can get ironed out with like a contract review, something before the PO is placed. Now, the next step is pretty obvious too, right? So once you've chosen a supplier, let's have a kickoff meeting. And a kickoff meeting has a lot of intentions, but I've seen this only be positive. Firstly, you want to make sure that both the sales side and the operations side of your test lab are on the same page. If you said I had an urgent job and the sales team's like, yeah, I can get that in right now. And then you send a PO in and the first thing you have a kickoff meeting and you talk to the ops team and they're like, oh, I just heard about this. And yeah, I was going to do it in a month from now. You're going to, again, that immediate frustration. So to avoid things like that, have a kickoff and make sure you meet the technical team handling the job. It's going to give you a good insight to their character, who they are, what they're good at. Now, it's setting goals also. And when I say goals, I kind of list them here, but as a test supplier of our own, I like to know what the customers are trying to achieve. Again, I don't think we excel at transactional projects. I think we excel when we work as a team. And so when our customers have a goal and we know it, we can tailor our responses, our efforts, all that towards what they're after. And without that information, we really don't know how to handle a request, right? We can work through a job at our own convenience, and that might be letting you down inadvertently. And we definitely don't want or expect to do that. And also, I think communication is a big one. So if you have a project and you say, hey, this is really hot, I need an update every day. Let's make that clear up front. The last thing you want to do is expect updates. The supplier's just, casually going about their work and not sending anything out. And then you get angry because you don't know what's going on. Again, a lot of that can be set up front with just good good kickoff meeting on the start of a project. But from here, we start developing something a little different. Again, it starts off as communication, but I like to say you want to test the waters. And I mean that in a very specific way is every test facility has a team of some kind there, and they all have differing talents and skills, right? You'll hear people give their ideas or reasons or rationale for things. What you really want to start doing now is learning the individuals you're working with and try and understand what the limits of what they know are. The worst thing I think you could be is have a test facility with an inexperienced person that's giving you advice as though they are experienced. And feedback and root cause analysis if they aren't aware. You really have to dive in and start trying to understand these people and what kind of skills or information they have or they don't have. Once you do that is the only time you can determine level of trust. If they keep telling you something and letting you down, obviously you shouldn't extend trust to them. But the goal ultimately is to develop the right level of trust, right? If you have a great supplier, that should be a high level of trust. If you have a very poor performing one, you should not give them trust. And if you don't, learn to work within that expectation to avoid frustration, right? And that feeds right into the last one, which is by the end of a project, I mean, I think the goal ultimately is to have a good relationship with your suppliers. Again, if you're aligned on expectations, if you're aligned on goals, you have good communication and you then know what each other is, where your strengths and weaknesses are on both sides. It goes from a single project with one goal in mind to having a test lab be able to fulfill the needs of your location uniquely, right? So if we have a customer that's weak in one area, we now know after building that relationship, how can we better serve you in that space? Do you need help getting a test plan critiqued? Do you need help talking to the certification authorities about a certain topic? We can dive into those kind of topics if we know you need it. But until that relationship's built, the service is just testing and the output's just a report. We'd like to get beyond that and get to a better place. And so kind of moving on to the last slide here is really now about the Jupiter location specifically. So this is where, what is it that makes our location kind of the center of excellence for a group? And I think it starts off with what I've been talking about here, communication. Our team really is focused on like a customer experience. And so we want to take our knowledge and our efforts and experience and pass that to you as often and as frequently as we can. One thing that we have is we have a really deep team of knowledgeable people in different areas. And one thing I see as a benefit is that if you look at our quotes we send or the managers in our lab, it's actually all driven by test engineers that have been there, done that. They learned how it works. They know what the customers need. They know how to get things done. And so our project managers, our department managers, our general manager, a lot of our sales team, they're all test engineers in their past. And I think that adds a lot of value to, we know what you need from the very beginning and what you're after to get there. The second piece really is kind of the things that are easy to overlook. I've been at facilities where if an emergency arrives, if something goes wrong, it takes, the right people are in the wrong time, and it takes a day or two to try and move on and fix that issue. We've rebuilt the Jupiter's structure, their daily meetings, the way that we communicate. So we have the fastest path of escalation. So if there's something that needs done or like something changed in the program, a unit's delayed or a thing we bought is delayed, we can usually resolve a lot of those issues within a day or the same, within the next day or the same day. We have our stand-up meetings every morning orchestrated around delivering information to the team and delivering up to our management and then back down as quick as possible. And so we're ready if anything changes, what happens. And that's really to increase our on-time delivery for services to you guys. And then the second piece of that is internally, we have test readiness reviews, design reviews, report reviews, all those sorts, our own kickoff meetings. And we take a lot of overhead on to make sure that we are giving the best outcome for a customer first time through. Some of those you can be part of if you ask. It's something that, you know, we can have customers be part of that experience as well. But these are all built in internally, and we'll also support yours as we go. And so that leaves us to the last thing, which is the technical experience and excellence. Again, I kind of mentioned that we have a team full of test engineers that kind of go through the gamut. And one thing that we do very effectively is we do an excellent job growing and training our engineers to be very well-rounded and have a deep experience in a lot of wide range of skills. We have our own training material that is generated internally. We have our own white papers giving us advice and guidance on why we do what we do. And again, we like to take our engineers and really hone in on obviously deep technical skills, but a wide variety of them, and soft skills, and, you know, scope management, and customer service, and the list goes on. We don't allow ourselves to be pigeonholed into a single specialization. We expect and we demand and we create a very wide skill set that our team has. And that really leads to an excellent customer service or experience, generally speaking, across our projects. So just want to share those things with you about how we could take those unfortunate events that make people frustrated through experiences, and how we try and prevent that. And a lot of it comes through communication, again, with the team. So that kind of wraps up. There's one last question here, just about reaching out. If you'd like someone here to reach out to you about any kind of discussion, quote request, experience you'd like us to be involved in, we'd be happy to. Just let us know. Otherwise, we can kind of open the doors up to any questions or wrap it up for the day.
Actually, I think while this is going on, we can kick off Q&A a little bit early. We've had a question hanging out in the attendee chat for a little bit from Mark. Can you guys outline the main differences between 1401 Bravo and Charlie, and whether C simplifies the test process or makes it perhaps even more difficult?
That is a great question.
That is a doozy of a question. That's why I wanted to give it a little bit of extra time.
Yes. So on a planning perspective, I think it makes things more clear. However, it doesn't make the test easier. The expectations from authorities, generally speaking, have become more rigid and more conservative. And so the main difference really is about the removal of two of the main test approaches, continuous operation and emergency operation, and combine it into one called sustained operation, and applying the highest level water content to a full flight cycle. So it's very clear, but not easy. And it also expects you to measure and quantify your water throughout test, which was never required, ironically, before. I know that's very brief. If you don't know what I'm talking about, you probably wouldn't know, but if you do know, I think you'll get that.
Awesome. Thank you so much. All right, that being said, let's go ahead and open the door to Q&A. We've got two experts on the line to answer any and all questions associated with any sort of advanced aerospace testing, fuel icing, you name it. We'll see what we can get. Feel free to type in the Q&A block or even in attendee chat. We've got everybody monitoring to see what we can get in here for the next few minutes. I think we'll give it one or two. And there's been a lot of really good questions during the presentation as well. Thanks so much, Andrew. Andrew writes, great presentation, and thank you very much. Yeah, we appreciate you being here. Last call for any questions whatsoever. And of course, just a quick reminder: if everybody is, or if folks have questions or any sort of feedback or anything that they've got after this webinar ends, you can always reach out directly to Element, which you'll meet our friendly inbound team, or you can go ahead and just give a call to Element Jupiter. You can ask for Dan. All right. Well, I think with that being said, I think we're good to go ahead and start wrapping. Oh, actually, no, we've got one last one right under the wire here. How can water content be measured constantly during the test? Is more specialist equipment required? Oh, good question from Mark.
Yeah, okay, that is a good question. The current solutions is there's really only there's probably one way that's pretty clear, and there's one way that's more research driven. So there are water analysis tools that are out there that are being formed. They're not widely used yet to do such low concentration live measurements. So we don't have that yet ourselves either. But for usually you take fuel samples and you do a Carl Fisher titration on each of those as you do. That will give you a spot check on how things are going. The titrations unfortunately take about half an hour or so to process, so it's not that immediate feedback for you, but it is something you can still do live and get data during testing. Comparatively, you'd have to do post-test water analysis only, and that just is you more or less in a very one way is you just run your test, and at the end you just drain things and figure out where the water's at the end and expect that you're in a good result. But there's no validation during test that way.
Awesome. Thanks so much for the question and the response. All right. Well, I think we're good to go ahead and start wrapping this. Thank you again to our speakers, Dan, David, for sharing their expertise. And thank you to our audience, all of you, for joining us today. We truly appreciate your time and engagement. A recording of this webinar will be made available to all registrants and published on YouTube here shortly, so you can revisit it and, of course, share it with your teams. If you have any additional questions, or if you're interested in leveraging Element's experts for your own fuel testing programs, please don't hesitate to reach out. You can connect with us via the contact link on this platform itself, or by visiting www.element.com. Thanks again, and we look forward to continuing this conversation and of course, growing the presence of fuel testing content, as well as the greater discussion of advanced aerospace testing as we move forward. Thanks all.
Thank you.
Thank you.